Differential equations, we are in the 4.1, 4.3 review number 2, and really we're going to be seeing that our test is in exactly the same format. You could expect that the third question on the test will be just like this, to find a second solution using a formula. And the formula that you're going to have, you'll always be given a first solution. That's kind of nice. You'll see that on the test just as well. But what we're going to see is that the second solution always will follow this formula. Take your first solution, multiply that to the integral of, we'll have e to the negative integral of p of x dx. We'll talk about what p of x is in just a moment, divided by your first solution squared. And, here's the thing. Of course, you are given a y1. You're given a first solution. But you're also given this very basic differential equation here. You can see that it's just equal to 0. And my goodness, all you got to do is to divide by your lead coefficient. And here's our brand new differential equation in this altered form. By the way, I hope you noticed that there was a 0y prime there. And you could say it's a 0y prime. You might be thinking, why in the world are you dealing with that? Well, here is why, guys. What you're going to see is, in general, your p of x is the function multiplied to y prime. Q of x is what's multiplied to y. And I definitely wanted to give you a problem like this, where p of x could be 0. And that's what it is equal to here. And perhaps you've heard the saying, sometimes something is so easy that it's hard. I think we can look back in notes, we can look in our textbooks, and we can see when p of x is some form of x or even a constant, it's easy to plug that into the formula. Sometimes we look at a 0 and we think, oh my goodness, what do I do? Well, let's just walk through this real quickly. I know that, x to the 1/2 is going to be coming in right in here. We'll have e to the integral of 0 dx. Wow, look at that. Down below, we'll have x to the 1/2 squared. And let's just continue on here. You could see that the antiderivative of 0 with respect to x is a constant. Put a negative in there, and it really doesn't matter, does it? And x to the 1/2 squared is just x to the 1. So I guess what I'm trying to tell you is, plain and simply, this right here is a constant. And tell you what, you could just pull that out in front as a result. You could just say, call that C2. If you'd like, e to some fixed number is going to be some fixed number, isn't it? And then we can say, well, what do we have for our antiderivative of 1 over x? Well, we could say it's the ln of x plus some other constant. Well, here we go. We could say this is a general solution. What if we let C2 equal 1 and C3 equal 0? Then nicely and quickly, we will get a second solution that we see right here. So we could say it's x to the 1/2 times the natural log of x. The way, in general, just one more comment. As soon as you see y is equal to x to the 1/2, that's really the square root of x, isn't it? and that means that x would have to be positive. Of course, you could have put absolute value right here by the natural log of x. I think I just mentally made a note of that and left it off. But you'll see a lot of times that's what in textbooks we'll have as well. We'll move on to our last video now.